Welcome everyone to today's webinar, Stay Steps Ahead in the Battle for the Best OTT Experiences. I'm sorry for the slight delay. We had some technical difficulties, but all good now. I'd like to introduce you to the speakers, which is Charlie Kraus, Senior Product Marketing Manager, and Ernest Russell, Technical Product Marketing Manager. Just a few things. If you have any questions during the webinar, feel free to submit them. We will address all questions after the webinar though, but it will all be addressed. I hope you enjoyed the webinar, and Charlie, I'm handing over to you now.
Okay, good day everyone. Let me just quickly run through the agenda here, matching the abstract we sent out. So first I'm going to talk about some market data. At Limelight we always do surveying on the sort of the state of online video viewing every year. I'll show you some of the a couple of key important things that we notice as we do this year after year. Then we'll talk about standardization. So with all the different platforms and devices and so forth and formats, it's getting pretty complicated for delivering OTT and other video. So there's moves afoot here to try to standardize some of this and simplify it. So we'll talk about some of those efforts, such as CMAF, small chunk streaming. There's some new technologies coming up to reduce streaming latency, which is a big request for live. And then we'll talk about ways of doing some interactivity to give new user experiences. And finally, always have to talk about cyber threats when we talk about security, and then a summary. So let's get going. Okay, so pretty obvious on the first one, online consumption is growing. Of course it is every year. And you just to compare the past 2 years, so this is sort of average total hours that worldwide, how many people watch online video at how many hours a week. So you can see since 2016, in 2 short years, it's just about added 2 hours per week in viewing. And the way this breaks down in terms of how much time, the next chart just shows how many people watch just a couple hours a week, et cetera, all the way up to 7 to 10 hours or 10 to 20 hours per week. So that has been growing as well as the number of people watching, very, very, large numbers of hours on this, and that keeps going up. Okay, the next one is that online viewing is starting to catch up to broadcast. In some countries, it already has surpassed it, such as India, Philippines, parts of Asia. In other countries, it's lagging, but not always so much. But every year we're seeing these gaps narrow. So it won't be long before the average online viewing is going to exceed broadcast. And we used to think years ago OTT as video on demand, but lately live is coming up big, certainly sports, even news. So those numbers are growing as well. So certainly movies, TV shows are still the most popular, but live news and sports, they're catching up as well. And then the final piece of data I want to give you has to do with latency. So on the live side, one thing viewers are clamoring for is reduced latency. And a lot of this is coming from what happens when you have a mixture of broadcast watchers and online watchers for a big sports event. And the thing you hear a lot is there's a match going on, you're watching online, you get a text from a friend of yours that's watching the broadcast about a goal that was just scored that you haven't seen yet. And you won't see for 45 seconds or a minute because of the typical online latency lag. So we're going to talk about several solutions to that problem as well. So I'm going to turn this over to Ernest for a while, and we're going to talk about the drive to standardization. And I'll be back with you at the back third of this for security discussions. Take it away, Ernest.
Thanks, Charlie. So there is a concerted drive to standardize video delivery within the industry. And a huge part of this is to create more efficiency. The key word here is efficiency. Using multiple formats to deliver video isn't cost efficient. There's time and also a compute time that's involved with processing various different protocols needed for multi-platform delivery. And then along with that, we have the complexity of the digital rights management. So with all the different video protocols that we use, for each of those, we have to process the DRM for those, or digital rights management. So as we reduce, one way we can reduce the time cost and compute cost is by reducing the number of protocols that we have to process. And along with that, there's a drive to reduce the overall live streaming latency. On top of the complexity that it takes to deliver to multiple devices, we want to be able to lower our latency so that we can increase viewer engagement and also introduce interactivity. So let's take a look on where we are now and where we've been with latency. So traditionally, or over the last 3 years, we've seen a reduction in the average live streaming latency. The traditional online streaming latency, as of a few years ago, was anywhere from 90 seconds to a minute of latency. And already we're starting to see a trend of reduction with typical HLS and dash latency. We're a little bit above 30 seconds of latency on average, but we've developed several methods to reduce that latency. The first I'll talk about is small chunk latency, or tuning the chunk sizes from HLS and dash in order to reduce latency. Also, there's chunk CMAF, which can get us in the latency of sub 5 seconds, which opens up a new world of possibilities. That's about where broadcast is 5 or 6 seconds. So once we're able to get below broadcast latency, it really opens up the possibility of interactivity. And so with CMAF and both WEBRTC, we achieve low latency and what we call ultra low latency with WEBRTC with sub-second streaming. And so now let's take a look at a very popular workflow used for HTTP streaming. So in a lot of today's CDN workflows, we have a video source coming in, which could be an RTMP source that's being transcoded to the multiple flavors that we need to deliver to multiple platforms, whether that be a phone, a tablet, a laptop, or an OTT device. So here it's demonstrated that we have an RTMP file in, and then that transcode is creating HLS chunks, dash chunks, HDS chunks, and Microsoft Smooth Streaming chunks. And all of those chunks have to be created in order to support the vast ecosystem of devices that we have out there. Another popular and similar way of delivering video through CDN would be to do the transcode or transmux on premise. And that way, instead of delivering a multi-bit rate RTMP file in, you would deliver the chunk stream into the CDN and just use the CDN to expand and scale that video delivery globally. And so that's an important step in our video workflow, is that transcode transmux process. So we can again create efficiencies by converging on video formats instead of supporting so many over time. So right now, HLS and Dash are winning that battle, and again, we can use configure chunk sizes tune chunk sizes in order to reduce latency with chunk streaming, but there is a balance. So tuning chunk streaming, we if we tune too low and create chunks that are too small, we can also create buffering. And so on the next slide here, let's talk about CMAF, which is also a popular or becoming more popular with CDNs as an efficient method of delivering and scaling video, and in particular live video. So CMAF is Common Media Application Framework. So CMAF itself isn't a protocol, but it's a framework to help simplify the workflow. And so the goal of CMAF is to help simplify that workflow, but also to increase latency to reduce latency. But in order for that reduction in latency to happen, several things have to come into place. And the first being on the bottom left here, our chunk encoding. Our encoder has to be able to encode chunks or micro chunks that are smaller than typical streaming format chunks, but start with a GOP or a group of pictures, a reference frame, and are smaller than typical chunks. The next part of the puzzle would be the updated manifest. We need a manifest that can describe the smaller chunks. The HTTP 1.1 method of delivery. So our CDN needs to support that method in order to carry those chunk streaming packets. And then finally, we need a dynamic player. We need a player that can read the updated manifest and adjust its buffer accordingly in order to play that shorter described chunk. And so when all of those come together, then our player can achieve playback within frames and reducing our latency to 2 to 3 seconds. And so again, CMAF is deployed using HLS or Dash, and it's not an alternative to them, but again, a framework. And when all these things come together, it does serve some benefits, and we're seeing some major adapters of this format, including Google and Apple, to deliver live streams. And so, again, this technology, what it does is CMAF creates very small chunks, and I refer to these as low latency chunks or micro chunks that enable the playing of a segment before the full segment is calculated or downloaded. And so decoding and playback can start within frames of receiving the first video. And because CMAF is delivered by HLS and Dash, our existing CDN infrastructure can easily support it. So there is promise for CMAF to support large events using our current infrastructures. And the last technology I want to talk about here is WebRTC based streaming. And this is something fairly new in our industry that we've been seeing, and able to achieve sub-second latency and anywhere in the world. So we're able to achieve sub-second latency at global scale. And its WebRTC technology was initially used for web conferencing. And so as it was adapted to live streaming, there was question about scale. And we'll look here shortly on how WebRTC is scaled. And so in addition to that lower latency, we also have a live data channel that's associated with WebRTC that can enable interactive online experiences. And so here's what that WebRTC delivery would look like. So similar to chunk streaming, where you would have an RTMP ingest or file coming in to a CDN. That signal is broadcast across to WEBRTC edge servers placed globally. And what that allows is, for one, WebRTC does not require video chunking. So it allows a broadcast that is in sync and is not going through the buffering and caching that an HTTP chunk streaming protocol would. And the result of that is reduced latency under 1 second. And so WebRTC, there is an investment being made to still be able to support some of the traditional things that we've seen in live streaming, like adaptive bitrate support for highest quality, and also, again, we have that data sharing for interactive applications. And when we're able to deliver in sub-second latency, it opens up some new possibilities. And some of those possibilities are, for instance, a live sports betting. So when we're in sync or we're sub-second with a live streaming event that's, say, live sports or betting, we can see in sync what's happening on the field and allow wagering on what's going on now. Who's going to kick the next goal, or who's going to make the next run, who's going to lead the next lap. And similarly for table games, when a live broadcast or sub-second latency allows for online players to experience a real-time and consistent action, just like they would if they were there in a casino. And then other technologies like auctioning and live trivia, where there's viewers on site interacting as well as remote viewers. And we want to be able to give those viewers the same experience. But no matter what experience that we're providing, security is always top of mind. And so that's where I'll hand back over to Charlie to talk more about security.
Okay, hi everyone. So let's run through some important topics on security. So I'm going to keep this focused on what pertains strongly with video delivery. Security is a pretty broad topic, and a lot of the security measures, are not strictly video focused. So we're going to stick to this. So I'm going to start with digital rights management, or DRM. So where this comes into play is it's for keeping access controlled to authorized viewers or subscribers, and sort of control over what they can do with videos. It's controversial. There's a lot of factions that don't think digital rights management is useful. They think it just inconveniences people that have rights to see some video. But nonetheless, a lot of like movie studios that have very high value, let's say 4K content, or if you're delivering licensed content, it may be a requirement as part of your agreement to deliver that content that you protect it from theft and unauthorized access. So you may have to do this. So what complicates digital rights management is there's not just one scheme for doing this, there's multiples. So there's Apple has FairPlay, Google has Widevine, Microsoft has PlayReady, and yet there are others as well. There are commercial DRM products available out there, and most CDNs do provide DRM solutions that include both the authorization servers and the license servers that are used so that the encrypted videos can be decrypted. So what happens is when you're a subscriber and you're authorized to view a video, when you go into a website to download and watch a movie, what you get is a license key that allows your player to decrypt the content. One of the things that will potentially simplify this is back to CMAF. CMAF supports something called common encryption. So this potentially might simplify the DRM process by simplifying the dealing with the different encryptions that are currently used between Apple, Google, Microsoft, and others. and simplifying that into a common encryption format, which may make this very, very easy at some point. Okay, forensic watermarking. So this is sort of adjunct to DRM. So DRM, again, will ensure assets reach authorized users, but once playback begins and they have it, it doesn't protect against things they could do about redistribution and so forth. So forensic watermarking, it's a pretty clever way to invisibly mark video files, so that the idea is if there's ever a leak and a file gets out that shouldn't be, it's possible to trace back where the originating file came from. So the way this works is video files are pre-encoded, and basically you take a video file and you create A and B segments of it. So they take certain lengths of time and they make an A version and a B version. The difference between them is invisible. And an algorithm will build a unique A and B segment pattern in the manifest for delivering that video. So what happens is somebody requests a video and it's going to be watermark protected. So an algorithm is generated of random A-B patterns unique to that particular download. So to explain sort of in a diagram how this works. So word from our sponsor. This is, I'm going to drift a little bit into actual products here. So this is a way at Limelight we do forensic watermarking. So first, there is about 8 companies that do have watermarking solutions that are happily very, very similar in that they use this A-B segment pattern type scheme. So the example I'm showing here is 2 that we're working with. One is Nagra, the other is Erdata. So what happens is a subscriber is getting a file. When they go to download the file, what happens is in our CDN, we have a dynamic manifest generation capability. And so the manifest is sent to either of these companies, and what they do is they generate a random pattern of these A's and B segments of the video, and then the manifest generation code will actually create the new manifest and the new video that's pushed out to the subscriber. And the video will consist of those A-B random pattern video images and so forth. So down the road, if anybody leaks that video out, if the studios or whoever owns the content gets a copy of the pirated or the leaked video, they can play back that video through their software, and it will basically reverse and come out with the ABB pattern, the A and B segment pattern, which can be looked up in a database, and that will tell you exactly who the subscriber was that originally downloaded that video, and hence the source of the leak. So it's not preventing the leakage of this content, it's a deterrent in that people can find out who did the download and who did the leak, and they can take legal action or prosecute for that or get fines for it. So it is a very strong deterrent. And just overall on security, I built one slide here that just tries to sort of wrap everything together, going around the clock of delivering video. So DDoS attacks, probably don't have to talk about that too much. You read about these constantly every day about large-scale attacks on Layer 3 and Layer 4 networks. And you just simply need detection mechanisms and ways of mitigating this quickly when they happen. And the important thing here is that the scale of these things in terms of how many gigabytes we're now terabytes per second of attack traffic is actually occurring, and that you need very, very strong solutions to counter that. We just talked about forensic watermarking. Global HTTPS, so when you're sending video assets generally around the world, you want to always have, DRM aside, whether you use DRM or not, you want to encrypt them. And this is done with either TLS or SSL secure services. Access control, so this is different ways of ensuring that only authorized viewers can get at video. So it's just simply having checking for somebody whether they're a subscriber or not, or using IP address whitelists and blacklists. There's various other like geolocations, which is the next thing. So you can restrict video to just people in a certain location. This often comes to play with licensing rights. As an OTT deliverer, you may have licensing rights to particular video content, but that licensing right might be very specific about what regions you're allowed to show it in. So you need some way of preventing that from being viewed by people in other regions. So geolocation will do that. And one of the things that geolocation schemes can do is they understand the common anonymizers that are out there. So there's these tools that help viewers disguise their location when they want to get at access to content that they shouldn't see. So common thing, sports. Sometimes there's regional blackouts done by broadcasters to prevent people from outside a region or inside a region from viewing an event as a blackout. So people try to disguise where they're coming from to be able to view it. The anonymizers that do that job are pretty well known. So the geolocation tools will also use that database to determine if there's an anonymizer in play that they will prevent access to the content. Then we have URL tokenization. So this publishes a URL, and again, this is checking that the person that's getting it is having to have access to that, and it's all up and up. And then finally, digital rights management, again, just going around the clock. So we talked about that already. So that is the end of the slides, and now we're going to open this up for any Q&A that's out there. Let me just give the quick summary here. So just a quick summary. So online video is catching up with traditional broadcast, as we showed from our data. CMAF is gaining momentum for OTT video distribution. It's still in the early stages, but there are definitely tests and some availability coming. So it's not a sure thing, but it is definitely on a track and gaining traction. Live online audiences just expect that this latency problem is going to be solved. They don't want to have spoilers when they're watching things about people talking about things they haven't seen. And that can be met with either HLS and dash small chunk streaming, as we talked about, or CMAF with microchunks, and WebRTC because it doesn't use chunks and it's UDP stream with adaptive bitrate. And something new, with the ability to do very, very fast sub-second streaming, there's the possibility to add live interactivity, either between viewers or between content owners and viewers. Because of the real-time nature of it, you can have live chats. And again, cyber threat measures discussed. You just have to protect your content and make sure your service is up and running. Just while we wait for some questions to come in, some housekeeping items. So there's going to be a follow-up email to everyone that attended or registered with a link to the on-demand recording of this presentation and a link to download the state-of-the-art online video report that I mentioned earlier, where I pulled a few of the slides. It's a big report with a lot of data that's provided with it on how the demographics we polled, all the tables of all the exact data by country and so forth. So it's pretty rich and useful data. And again, feel free to share that document and the download link of this webinar with friends that couldn't make it. Okay, questions. Let's see, the first one I have, when we talked about small chunk streaming, and I guess I'll apply this to either HLS or Dash, there must be a reason that large chunk sizes have been used. Why all of a sudden are we able to deliver small chunks? Well, as we discussed, the reason for the larger chunk sizes is to build a buffer. And with the improvement in the quality of internet connections and networks in general, it's now possible to have smaller buffers out there. But it really depends on region. I can't make a statement that every region in the world is going to have high-quality, last-mile internet connectivity that would allow very, very small chunks. So it can become a regional issue. But there is some limit. You can't take HLS and Dash down below 1 or 2 seconds in reality, because what happens is, because it's chunk streaming and there's always acknowledgments and there's protocol overhead, if you get below a second, the protocol overhead going back and forth to move those chunks will actually start negating the effect of the lower latency. So it's sort of a crossover point. So 1 or 2 seconds is really all you can do there. But I don't want to imply that low latency has to mean sub-second. If you take the simple case of broadcast versus online streaming, you don't really need sub-second to solve that problem. Broadcast isn't zero latency. Broadcast is typically in the 5 to 8 second range. So small chunk streaming good enough to just get it down in the 5 to 8 second range will solve this two-screen problem with the latency lag on online. So just from that viewer's perspective, that's good enough to do the job. The lower latencies are when you start involving interactivity, where it almost has to be a second or below to have that realistic chat back and forth, or when you talk about auctions and bidding and so forth.
Thanks, Charlie. It looks like
take one.
Yeah, it looks like Carlos has a question, and his question is, how can these forensic security measurements prevent screen captures from happening? And so the forensic watermarks that Charlie spoke about aren't just to prevent necessarily screen captures, but what it does is it will identify the user that does that screen capture or that has that video, and that's because that video is marked with a unique pattern or a pattern that is unique to that user. So the manifest is unique, and the AB pattern of the video segments within that stream. And so that's how there's an algorithm that can go in and identify exactly who that user is and trace it back to the source. And also, looks like Carlos had a second question here. In the WebRTC workflow, since the contribution side is done with RTMP, does that defeat the purpose? That's one example. We want to support what's currently out there, and RTMP is a standard output that you can get out of many both broadcast and consumer encoders, but also we are looking to support other formats, including SRT for ingest.
Yeah, good point. I mean, you're right. SRT is getting a lot of traction as well right now. Again, it's not universally used, but it's on the horizon, and that is potentially, like CMAF, a good potential for a standard ingest. You have another? I have one. This is about when you're watching on mobile devices and you're talking about the chunk streaming. It says, does adjusting the chunk size to minimize latency have repercussions with delivery on tablets and phones? What they're getting at here is, the CPU power to have to process more of an algorithm to receive smaller chunks and the headphone and the head of back-and-line communications, and whether that's an issue. And it's really now, the segment size differences really don't require any special handling in these devices, since the segments are still following HLS and dash format specifications. Basically all players, or modern players, will support the smaller segments, and it's not really a CPU-bound issue anymore. So I wouldn't expect to see any issues with that. Anything else, Ernest, on your side, or are we done?
No, it looks like that is all the questions that we've had come in. Thank you very much, everyone, for joining and participating.
And again, watch for the email with the link and the download of the white paper. We hope this is informative to you, and we look forward to having you on another webinar in the future. Thanks, and have a good rest of your day.
Thank you.